If cancer runs in your family, knowing you're at average risk instead of increased risk can be a massive relief. That's the power of a true negative, but only if testing starts with the right person.
Let's say this is your family. There's your mom, your dad, and you. And your mom was diagnosed with breast cancer. If you come in to get your genes tested to look for all the genes associated with breast cancer, we're just kind of casting a really wide net, right? So let's say we test you and you're negative for any mutations in any of the genes on this large panel. But we still don't know your mom's genetic testing results. In this case, we don't know if you're truly negative because you didn't inherit whatever gene change your mom had, or if your mom didn't have a gene change to begin with, at least that's detectable by our current technology. It could be either of these situations, and the only way to know is to test your mom. Now, let's say your mom actually tests first, since she's the one affected and therefore most likely to carry a mutation if there is one. And let's say she tests negative. Then you actually wouldn't need to do testing unless there's reason for suspicion coming from the other side of the family. Because if you don't have a mutation, you can't pass it down. But if your mom is also negative and you're negative, then your negative is what we call an uninformative negative, because we still don't know what's causing the cancer in your mom, and therefore we have to assume it's either not detectable or it wasn't something hereditary. But now let's say your mom tests first and she actually is found to have a very specific gene change. Then we know exactly what to test you for. And if you test negative, knowing your mom is positive, then you're a true negative, which means we know that you did not inherit this genetic change and therefore did not inherit the risk in your family. Also important to note that even if you're negative, your siblings may still be positive, because if your mom was truly positive, then each child she had a 50% chance of inheriting this specific mutation. It would tell us that your child wouldn't have it because you don't have it to pass down. The gene mutation itself does not skip generations. So you can see why testing the person affected first is really helpful in determining who else in the family needs testing and exactly what to test for. Now, we totally understand that this isn't possible for every family. A lot of times the affected relatives have passed away or refuse testing or can't afford it or for some reason just can't get tested. And that's okay. You can still fit criteria for testing based on family history. So if your doctor won't order it, I recommend talking to a genetic counselor.